Morning students. Today we will study division algorithm for polynomials and do exercise 2.3 of the NCERT. Now division algorithm is something that you are already familiar with. You know this since the time you started doing divisions. The algorithm that you studied in the simple form is dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. Now if we talk about polynomials, so if we say dividend is the polynomial px, divisor is the polynomial gx, quotient we denote by polynomial qx, and remainder we denote by polynomial rx. So the rule becomes, algorithm becomes dividend, that is px, is equal to divisor, that is gx, into quotient, which is qx, plus remainder, which is rx. So division algorithm for the polynomial says if px and gx are any two polynomials with gx non-zero. We know if we need to divide, the rule says the divisor has to be non-zero. If gx is non-zero, then we can find polynomials that we can get quotient and remainder qx and rx such that px is gx into qx plus rx, where either the remainder is 0 or the degree of the remainder is less than the degree of divisor. This is how we do normal division. We stop division either when the remainder is 0 or the remainder is less than the divisor. So in polynomials, how do we decide that less than? With the help of degree. So either remainder comes out 0, we stop our division, or the degree of the remainder is less than the degree of the divisor, we stop the division. Let us take an example. Now in order to explain, I have taken the question from the NCERT book only, exercise 2.3, question number 1, third part I have taken. The polynomial is x raised to power 4 minus 5x plus 6. And the divisor given is gx is 2 minus x square. So children, you have already done division in class 9 also, and you remember the basic rules of division of polynomials. And the rule is both the divisor as well as the dividend should be in the standard form. In the standard form means the terms should be arranged in the descending order of their powers. That means the term which has have the highest power of the variable should come first, following the terms of the powers in decreasing order. For example, here gx, see here px is x raised to power 4 minus 5x plus 6. All these terms are arranged according to the decreasing power of the variable. So this is already in the standard form. Fine. Now the divisor gx 2 minus x square. This divisor is not in the standard form. We have the term which is the term with the highest degree, x square minus x square. So this should come first. So I need to rewrite this divisor, and if I rewrite this divisor, it will be minus x square and this plus 2. So now this divisor is in the standard form. So now we start dividing minus x square plus 2 the divisor, and the dividend x raised to power 4 minus 5x plus 6. So let us start dividing. I want x4 here, x raised to power 4 here. So this is positive. So how do we get a positive number? I need to multiply it by minus. So minus x square, by what number should I multiply minus x square to get x raised to power 4? So how do you get it? X raised to power 4 by minus x square. So the number is minus x square. Minus x square. Right? Now we multiply the same term with the other term of the divisor. 2 into minus x square gives us minus 2x square, which is not there. The term with x raised to power 2 is not there in the dividend. So I have written it separately here. So this goes away, sign changes, this goes away, now the sign changes here also. Now there is no term, This is the term with the highest power. So I have written 2x square first. then minus 5x, then plus 6. Now we will multiply minus x square by minus 2 to get 2x square. So I get 2x square. Now when minus 2 and 2 are multiplied, we get minus 4. So we get, now when the signs are changed, this cancels and I get this plus. Minus 5x plus 10. Now what is the degree of the divisor? 2. And the degree here is 1. So the degree of the remainder is less than the degree of the divisor. So we stop dividing. So this is my remainder Rx, and the quotient, this is my quotient Qx. So write down quotient is this, remainder is this. In the question he wanted you to divide and write the quotient and remainder. In the next question, question 2, he wants you to check whether gx is a factor of px. You all know when is a polynomial, a number is a factor of a given number if the remainder is 0. Now, in the same question, if I say, check whether gx is a factor of px. We divide, we have to divide, we have already divided. What is the remainder? We have already divided it. Now, what is the remainder here? Remainder is minus 5x plus 10. But in order to be gx a factor of px, the remainder should be 0. Here the remainder is non-zero. So in that case you say Rx is not equal to 0. Therefore gx is not a factor of px. So the solution remains same. You need to divide and just need to observe the remainder. If remainder is 0, you say yes, gx is the factor of px. Otherwise you say no, gx is not a factor of px. Fine. Now I would like to take up an example, solved example, where a polynomial px is given 2x raised to power 4 minus 3x cube minus 3x square plus 6x minus 2. Px is 2x raised to power 4 minus 3x cube minus 3x square plus 6x minus 2. And it is given that root 2 and minus root 2 are the two zeros. And he is asking us to find the other zeros. He is asking us to find all the zeros of the given polynomial. Now observe what is the degree of the polynomial. Degree of the polynomial is 4. So you remember how many maximum zeros this polynomial can have? The maximum number of zeros is equal to the degree of the polynomial. So the degree of the polynomial is 4. So this polynomial can have at the most 4 zeros. 2 zeros are already given. So we need to find the rest of the zeros. How can we find the rest of the zeros? We remember if root 2 is a 0, what will be the factor? X minus root 2 will be the factor. And if minus root 2 is a 0, the factor will be x plus root 2 be the factor. And if we multiply, we will get the polynomial, quadratic polynomial. But there may be some, you remember k into x minus alpha into x minus beta. We learned yesterday in the video how to write a quadratic polynomial directly using the formula. The formula was x square minus sx plus p. X square minus sum of zeros into x plus p. So we will use better this formula. First find the sum of zeros. What is root 2 minus root 2? Root 2 minus root 2, sum is 0. What is product? Root 2 into minus root 2, that will be minus 2. So according to formula, x square minus 0x plus minus 2. So this becomes x square minus 2. So I get x square minus 2 is a factor of px. If it is a factor, it should divide. So let us divide. Now we are dividing the given polynomial by x square minus 2. If I divide, I'll have to first multiply it by 2x square. So 2x square se multiply. 2x raised to power 4 minus 4x square. So written under the term x square. Change the signs, this goes away. Now minus 3x cube, this will be plus x square plus 6x minus 2. Now it will again go by, we need minus 3x cube. So by what should I multiply x square to get minus 3x cube is minus 3x. So we multiplied minus 3x cube. Now minus minus plus, see minus 2 into minus 3x. What do we get? Minus minus plus 2 into 3, 6x. So we get 6x here. Now change the signs. This goes away. We are left with x square minus 2. X square minus 2. Now this will go by plus 1. So x square minus 2, when we change the signs, we get the remainder 0. Otherwise also we started with x square minus 2 is a factor. So the remainder had to be 0 only. Now our polynomial, given polynomial can be written as x square minus 2 into 2x square minus 3x plus 1. Therefore, because remainder is 0, dividend is equal to divisor into quotient plus remainder. Remainder here is 0. Fine. Now other zeros, this is already obtained by the zeros. So I need to get the other zeros we will get by this quadratic polynomial. We will get from this quadratic polynomial. Therefore other zeros are given by, now we know the procedure how to find the zeros. I need to equate this polynomial to 0. Since degree is 2, so I'll factorize this polynomial and get the zeros. So equate this polynomial to 0, factorize it. We splitted the middle term to factorize. So 2x square minus 2x minus x plus 1. 2x common, x minus 1 minus 1 into x minus 1. So equated the factors to 0 and I got x is equal to 1 and x equal to 1 by 2. So the other zeros are 1 and 1 by 2. I hope you have understood this. Now I'll take one more question, similar question, and that question is of your exercise, question number 3, exercise 2.3. Same way, he is given you a polynomial px 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5. And the zeros are root 5 by 3 minus root 5 by 3. Why I am discussing this question? Because the zeros are given in fractions here and in the root. So let us discuss this. Sum of zeros, again we have to find out the sum of zeros and product of the zeros and get a quadratic polynomial which will be the factor of the given polynomial. So sum of the zeros, of course, 0. Product of the zeros, when we multiply we get minus 5 by 3. Substituting in the formula quadratic polynomial x square minus xx plus p, I get x square minus sum of zeros is s is 0, so 0 into x plus minus 5 by 3. I get x square minus 5 by 3 as the quadratic polynomial. Now, since this is in fraction, I can rewrite it as taking the LCM 3x square minus 5. Because you remember k times x minus alpha into x minus beta. Now if I take, actually what we have done, we have taken x square minus 5 by 3, I have taken the LCM 1 by 3 outside, 3x square minus 5. So 1 by 3 is taken care of by, this is gone. This will be the zeros we will get from 3x square minus 5, no problems. So 3x square minus 5 is the factor. Now 3x square minus 5 is a factor of px. So let us divide the given polynomial by 3x square minus 5. When we divide by 3x square minus 5, it first goes by x square because 3 coefficient is already same. All I need to make the power of the variable same. Here the power of the variable is 2 and here is 4. So we multiplying it by x square to get 3x raised to power 4. So 3x raised to power 4 minus 5x square. So written x square under the term of x square. This goes away, 6x cube. Now minus 2 plus 5 is 3 plus 3. So plus 3x square minus 10x minus 5. Now by what number should I multiply 3x square to get 6x cube? 3x square. What number should I multiply to get 6x cube? So the number will be 6x cube divided by 3x square. So we get 2x. So by 2x we multiplied this. So when I multiply this by 2x, I get 6x cube minus 10x. So x under the term. Written the terms under the terms. This goes away, even this goes away. I am left with 3x square minus 5. And this goes by plus 1. We get the remainder 0. So now we can write px as dividend is equal to divisor into quotient. Remainder is already 0. Now other zeros will be given by this polynomial. To get the zeros, we equate the polynomial to 0 and factorize by splitting the middle terms. And we see this is x plus 1 whole square. So other zeros are x plus 1 into x plus 1 equal to 0. So x is minus 1, x is minus 1. Therefore, all the zeros of the given polynomial are minus 1, and plus minus root 5 by 3, which were already given in the question. I hope you understood. Now students, open your textbooks, or if you do not have the textbooks, I have provided you with the link in the group. I hope you must have downloaded the textbook. That was free download. Now, exercise 2.3, I have discussed question 1, third part. I have discussed question 2 also, how to do. I have discussed question 3. Now the question 4 says, on dividing a polynomial by another polynomial, quotient and remainder are given to you and you need to find the divisor. So substitute in the division algorithm and solve, you will get the answer. In the last question of this exercise, he wants you to frame the examples on your own such that polynomial, the dividend, divisor, quotient and remainder, so that these conditions are satisfied. So you can frame examples on your own. Try to frame the examples so that these conditions are satisfied. Where degree of px is equal to degree of qx. First one. Px, degree of px should be equal to degree of qx. Quotient, and try and understand, px is dividend and qx is quotient. Quotient and dividend ka degree should be same. Dividend is somewhere here and quotient is here. Degree of quotient and degree of dividend is same. That will happen only if you divide by a constant number. So think on your own and frame examples satisfying these conditions. Now I would like to draw attention to the third part of this, and the third part says frame such an example where degree of remainder should be 0. Now here you need to be careful. He is asking you to be degree of remainder should be 0. Degree of the remainder will be 0 when the remainder is a non-zero real number. So you need to be watchful here that the remainder should not be the number 0, rather remainder should be any other non-zero real number. Because if the remainder is 0, then the degree will be not defined. Because 0 is a special polynomial whose degree is not defined. And in the question he wants you to frame the example where the degree of the remainder is 0 and degree of all non-zero real numbers is 0. So constant polynomial has degree 0 and all non-zero real numbers are a part of constant polynomials. So I hope you understood this exercise 2.3. I'll be soon back with another video where we will do some extra questions based on whatever we have studied till now. Thank you.